Now let's talk about secure communication and some secure communication tools. So we will start with VPNs, then talk about TLS, IPsec, and then some other security tools and ways to access securely. So what is a VPN? A VPN is a tool used to connect to a private network via the internet. When you want to connect to work, for example, or when you want to watch a video in a remote location, you're connecting to a private network via a public network, which is the internet. So VPNs allows users to access resources like files, application, streaming as if they were physically connected to the network. So it's like you're internally connected, but you're connecting from a remote location and you're changing your IP address to the location which you're connecting to. VPNs encrypt your internet traffic and protect your online identity. So it's not possible to know where you're connecting from because your IP address and online identity is changed. And it's really almost impossible to track you when you have a good VPN because your IP address is hidden. And let's look at two ways in which VPNs can work. First, you can use a VPN to change your location. So here you have Ola with his IP address. He's connecting to beIN Sports in France to watch a soccer game. But take note of this. His IP address starts with a 71 and IP addresses here only allow from 104 to 204. This is just an example. So when he connects, you've probably seen this before on YouTube or on other social media. You get something like this video is not available in your geographic location. Now, next thing Ola does is he changes his IP address by using a VPN software. And when he connects, it's now in the range of IP addresses of that location. So what happens? He's able to watch the game. That's one way in which you can use a VPN to change your IP address. Another way in which you can use a VPN is to encrypt communication. So suppose here you have Anna who is trying to make a payment, posts her credit card on the website with the expiration, billing address and everything. When she posts her credit card, a hacker can get a copy with the right tools like Wireshark and all the network configurations. But if you have a VPN, if Anna uses a VPN like NordVPN, when she tries to upload her information, the hacker will not be able to get the details of her credit card and all because the VPN encrypts communication. And we have a partnership with NordVPN. So if you go to our website, you'll have a chance to get a 60% off deal with NordVPN. Now, there are two types of VPNs. There's a site-to-site VPN. So this is, imagine here you have Bank of America with one of their remote offices in Atlanta, Georgia, and their corporate network in Charlotte, North Carolina. So what happens is there are two VPN devices that connect the different locations. So the remote office and the main office can communicate securely with the site-to-site VPN. So it connects two sites across the internet together and shares data in an encrypted form. And you have a remote access VPN. A remote access VPN here, you have Dede who is trying to connect to a corporate network from a remote location, so from home. And what happens is her communication goes through a VPN concentrator before she gets access to the internal network. So she connects from her location via the public internet to the private location. So you have a site to site from one site to another, and you have remote access. SSL TLS is an important technology used to encrypt communication. So in the web browser, you have SSL TLS. This is a combination of different types of encryption to provide security. And SSL TLS uses encryption to provide security to HTTP, and that will give HTTPS over port 443. So HTTPS, when you go on the website and you type in HTTPS www.website, it actually uses a technology called SSL TLS to encrypt communication. So HTTPS is simply HTTP with the addition of SSL TLS. And here's an example of how it works. So here you have Aaron trying to communicate with Irma, and you have a hacker who is trying to read the communication. So when Aaron sends her a message, the hacker can get a copy and read the communication. This is on port 80. It's not encrypted, and hackers can read that communication in clear text. With HTTPS, what will happen is when Aaron tries to send a message, first the message will be encrypted with SSL TLS. So next, if the hacker tries to read the communication, it will not make sense. It will be encrypted. So it will be in a set of unreadable characters. So as a summary, HTTPS is HTTP with the addition of SSL TLS. Now there's a technology called IPsec. IPsec is used to encrypt internet packets. So it's used to provide secure communication by encrypting packets. Now you will ask yourself, what is a packet? A packet, here you have Frank in Canada and you have Sheila in Atlanta, Georgia. And you have Frank who is trying to send a message and he's like, hi, my name is Frank. Pleasure to meet you today. Let's go. What happens when Frank sends this message to Sheila in a network? What exactly happens is like the message is broken down into different packets to be transferred to the network. So when you download a file from the internet, you don't download the whole file as a whole, like a picture or a PDF file, but you're downloading smaller portions. It's broken down into smaller portions and reassembled at the end. For example, this is the first packet. This is the second packet. This is the third packet. So the message is broken down into smaller packets and it's reassembled at the destination in the right order. So Sheila gets the message in the right order. Hi, my name is Frank. She gets it in the right order in the way Frank sent it to her. That's a packet. Now, we said IPsec is used to provide secure communication by encrypting each packet sent in a network. So this is what happens. Now, the packet is encrypted. So a hacker cannot make sense out of this and cannot extract a packet and read the communication because it will not make sense to the hacker. But at the destination, Sheila will still read the message normally because the message is encrypted. So IPsec protects internet packets. Now, IPsec has two key components. There is one called authentication header, AH. This is used to add integrity to packets to make sure that packets are not modified. So when you say, hi, my name is Frank, the packet that has, hi, my name, should arrive the way it was sent. So authentication header makes sure that packets are not modified so that Sheila gets exactly what was sent to her. ESP, encapsulating security payload, provides encryption and authentication to packets. So it makes sure that the packets are secure and authenticated at the destination. So these two, AH and ESP, add security to IPsec or are components of IPsec. And again, for packets, they don't necessarily have to be messages. PDF documents, videos, images, audio files, any file you can think of is transferred over the internet by packets. There is a newer technology, a relatively newer technology called SASE, Secure Access Service Edge. SASE is a network architecture that combines wide area networking and network security services. And an example of where SASE is seen is adding remote workers to the network infrastructure without major infrastructure changes. So employees across corporate resources can securely access the network from home or mobile locations without major infrastructure changes. So SASE is a network infrastructure that combines wide area network and network security services like secure web gateways, cloud access security into one single service model. And this is the future of wide area network because with the proliferation of cloud services, the increase in the number of network remote users, and everything is all over the place, like customers are all over the place, employees are everywhere, contractors and third parties are spread all over the place. So there needs to be a way to connect systems and services as physically close to users as possible while maintaining security. And that's where SASE comes into place.
All right, guys, was that interesting? Subscribe to our YouTube channel. Trust me, you will not regret it. Also follow us on our various social media platforms, including Instagram, LinkedIn, Twitter, and Facebook, and more, to be the first to know about the awesome content that we're prepping for you guys. Thank you for your attention. Hope to see you on the other side.